It's 1 o'clock. Let's get started here. Welcome, everybody. My name is Suresh Srinivasan. I am the coordinator of the Minneapolis Astronomical Society's Beginner Special Interest Group, or BSIG. Today, we have a really neat presentation. Dave Falkner, our Renaissance man of the MAS, is going to present about the NASA Artemis program. Dave is a lifelong astronomer or amateur astronomer. He's from Indiana originally. I don't hold that against him, even because since I'm from Chicago, but he's a cool dude anyway. Dave had a full career in the Navy. I don't know how 20 years, Dave, I think.
20 years. Yep, both 20 years in the
20
Navy.
years. And then he moved with his family to Minnesota and joined the MAS. And he's had multiple roles in the club. He was most recently club president about 4 years ago. And actually, not most recently, because since then he was secretary of the club.
Yes.
He's a NASA ambassador, which is really cool. I think, what do we have? 4 NASA ambassadors in the club now, Dave? Something like that? 3? Something like that?
I think we had 4.
4. And he's written some books. He's written Mythology of the Night Sky and The Stories of Astronomers and Their Stars, which if you got the invite, you could find the link to that, to both books in the email. So with that, I'm going to turn it over to Dave. A couple of just side things. If you have a question or comment, please put it in the chat. If you click on the chat on the bottom, there's an icon there. Put it in there, and what I'll do is when Dave pauses, I will ask your question. That keeps the flow going. And then, of course, at the end, we also have Q&A. And then the other thing I'd like to ask is just everybody just keep themselves on mute in the meantime. I'm going to turn my camera off too, just to save a little bandwidth. So if you guys don't mind doing that. And with that, I'm going to turn it over to Dave Falkner.
Thanks, Suresh. So I'm going to do a little introduction here, and then I'm going to turn my camera off too, so that we're distracted. But a little bit about the Solar System Abbassador program. That is a NASA program. We are volunteers for NASA. We're not employees of NASA. It's actually administered by the Jet Propulsion Laboratory, and there are about 1,200 or so of us nationwide. And we go around and talk to the general public about space exploration, and NASA missions in particular. And so that's what we do. And then I'm going to preface this talk today by saying that all of this was relevant till about January 19th, 2025. So since then, there have been some developments. I'll talk a little bit about that at the end. Okay, and then I want to, okay, this is okay, and then I want to go ahead and mute the video. All right, so it's been 50 years since, is there a question? Okay, it's been over 50 years since man set foot on the moon, and since then, we haven't done a whole lot, but there has been some renewed interest in humans going back to the moon and using the moon to explore the world, such as Mars. And so I thought it might be interesting to hear what NASA's plans are for returning to the moon. Before I get started, though, let's have a little bit of a background. The first manned space program was in response to the challenge between the United States and the then Union of Soviet Socialist Republic, or the Soviet Union, who were the two superpowers in the 60s and 70s. And their goal was to dominate space by demonstrating that they could put a human on the moon. And so that's it got started with the Mercury program, and then the Gemini program, and then of course the Apollo program. And so we were, of course, successful in being the first and only nation to put a man on the moon. And since then, we have put 12 men on the moon. This image you see here is an image of Apollo 17, which was the last Apollo mission to the moon. We put Gene Cernan and Harrison Schmitt on the moon, and they managed to gather up some 243 pounds of lunar material and did some science on the moon. And they were the last humans to set foot on the moon. On December 17th, 1972, at 10:54, they blasted off in the ascent module back to the command module and returned back to Earth. And since then, we have had no humans on the moon. In fact, through the 1970s, then there were a couple of more missions by the United States and the Soviet Union that were robotic missions to the moon, and that was really about it. And interestingly, you can see where we spent a lot of money on the manned space program because that was our focus, and that was kind of a national focus on that. And since then, the amount of money that's gone to NASA has been kind of dwindling off. NASA, of course, went to more of robotic type spacecraft, very successful there with Voyager, Cassini, and several other ones. And so it's only recently that we've begun to take an interest in returning to the moon and budgeting for that. Um, After the 1970s, we had the 1980s, and I thought it was fascinating to find that during the 1980s, there were no missions to the moon by any nation at all. I thought that was kind of interesting. It wasn't until the 1990s that, again, the United States and now Japan started sending probes back to the moon, doing some exploration of the moon and discovering, uh, most notably, that there was some water on the moon at this, in the craters that had shadows that where the sun never shone, and there was evidence of water ice there. And then in the 2000s, we started seeing that there were more and more interest in the moon, and we see China and India beginning to send space probes to the moon as well. So uh, that's kind of setting the stage for it. And then in the early 2000s, the NASA Administrator Sean O'Keefe and President George W. Bush at the time created what was called the Vision for Space Exploration. And out of that came the Constellation Program, which is in response to the goals that were placed in this vision for space exploration. And the NASA Authorization Act of 2005 then gave funding and kind of a path for this program to uh, with basically three major goals. One was to complete the International Space Station, then to send a crewed mission to the moon by 2020, and to plan a mission to Mars after that. The program had some major components to it. One was the Ares rocket, which on the left there you see the two variations of that. They used propulsion systems and technology from the space shuttle program, which was winding down at that time. The Ares 1 rocket on the left would be used for crewed missions into low Earth orbit, with the second stage that would send them into what they call the translunar injection. And then the Saturn V, excuse me, the Ares 5 rocket on the right would be used primarily to deliver payloads to the moon. The spacecraft itself would be the Orion spacecraft at the upper right. It was a crew module that was similar to the Apollo module, but much larger. It could accommodate 4 to 6 astronauts, and then it would have a cylindrical service module attached to it that would provide the primary propulsion systems and supplies, and also have the launch abort system atop it in the event that something would happen during launch, that they can separate the module from the launch system. And then on the bottom right is the Altair lunar lander. It's about 5 times larger than the lunar landers that were taken during the Apollo program. Similar construction in that it was two parts. Had the descent module and the ascent module. The descent stage housed supplies and equipment and would stay on the surface, with the ascent stage would have 4 astronauts in it, and that could launch and separate and go back to the command module. Of course, with every presidential administration comes a new space policy. And in 2009, the Obama administration conducted a review of the Constellation program, and it was deemed unrealistic and was running about $3 billion over budget. So NASA terminated the program in February of 2010. Again, new presidential administration, new space policy. When President Trump, in his first term, came in, he instituted a new space policy. And beginning in 2017, President Trump issued his first space policy directive. And over the next 3 years, his directive set the stage for joint ventures between NASA, international agencies, and commercial companies for space exploration. You can see I highlighted a few key things here. Space exploration with both commercial and international partners, return to the moon for exploration and utilization with human missions to the Mars beyond that. Streamline the DOT, the Defense and NASA licensing and regulations for commercial space flight launch and recovery vehicles. Of course, he established the United States Space Force and promoted the private sector for growth in space exploration. So you can see the other bullets there too. And probably most importantly is that he provided the funding to support this space policy. And from that, from the new space policy directives, NASA created the Artemis program in 2017. The Artemis program had the key objectives of returning to the moon. You want to land the first woman and the next man on the lunar surface, have a sustainable lunar presence there by establishing infrastructures for long-term exploration, scientific discovery, explore and utilize the resources, have a global collaboration with this, so work with both commercial and international partners, and then use the moon as a stepping stone for interplanetary exploration to Mars and beyond. The logo itself has a specific design to it. First of all, Artemis is the twin of Apollo. So she is the twin sister. She was also the goddess of hunting and the moon. So the A, the black A there, represents the arrowhead, the tip of Artemis's quiver, and represents launch, with the tip of the A pointing toward the moon and things to come. The gray semicircle represents the moon, which is our next destination. The blue crescent signifies the Earth and Artemis's bow, as well as the source of power to return to space. And the red line there signifies the trajectory to the moon and ultimately to Mars. Artemis 1 is the first mission. It was an uncrewed test flight, and NASA began development of a launch system and a capsule to deliver humans to the moon. And this was the first spacecraft for humans, built for humans, to be launched toward the moon since the Apollo program. Total mission was 28 days and 10 hours. And it used the Orion spacecraft. We'll talk about some of the other components here in just a second. The goals were testing the Space Launch System, the Orion systems, and ensuring safety for future crewed missions. So it consisted of the Orion spacecraft, which we've talked about a little bit already, but there were 4 components to that. And I should say also that these were part of this commercial collaboration that we were talking about. So the launch abort system there at the top was built by Orbital Sciences and Alliant Tech Systems. And of course, it's designed to separate the capsule from the launch vehicle in the event there's a problem with the launch vehicle. The crew module, which is next, which is manufactured by Lockheed Martin. The ESM, the service module, is manufactured by Airbus. And the ESM propels and powers the spacecraft as well as stores oxygen and water for the astronauts. It might be noted that this spacecraft uses solar power for electricity rather than the fuel cells that were used during the Apollo mission. And finally, the spacecraft adapter, which is built by Teledyne Brown Engineering, which adapts the crew module, service module to the main launch system. The Orion crew module is a reusable capsule and can be configured in a number of different ways. There's crew habitat, there's storage for consumables, there's storage for research instruments, and of course the docking port so they can transfer from the Orion capsule to other modules that they will connect to in the course of getting to and remaining around the moon. This upper picture shows it configured for a crew launch. The lower picture shows it outfitted on-orbit configuration that would be used in crewed missions, storing supplies and the like. The Space Launch System is a super heavy lift expendable space vehicle. Um, it was designed to place the Orion spacecraft in orbit for a translunar trajectory. It's a replacement for the retired space shuttle as well as for the canceled Ares 1 and Ares 5 launch vehicles, but it used several components from uh, those uh, those uh, those programs. So it uses the hardware from the space shuttle, the solid rocket boosters, for example, and the RS-25 first stage engines. Now the SLS comes in different configurations, if you would, called blocks. So there's block one, a block 1B, and a block two. So the block one would be used for Artemis missions 1, 2, and 3, block 1B for Artemis missions 4 through 8, and block 2 for Artemis missions 9 and beyond. All three use the same core stage on the bottom there, along with the solid rocket boosters. It's designed to propel the upper stage of payload to near orbital velocity. Contains the RS-25 rocket engines and the associated hydrogen and oxygen tanks, the avionics and control actuators. All in all, it measures about 213 feet long by 28 feet in diameter, so pretty good size. The Block 1 upper stage has what's called the interim cryogenic propulsion stage, and that is a modified Delta rocket that will boost the Orion spacecraft into low Earth orbit and then subsequent translunar injection, as they call it. Then you can see with Block 1B and 2, there's a larger upper stage there called the Exploration upper stage. It's a much larger upper stage unit, and it has 4 engines capable of propelling larger payloads in the translunar orbit, or translunar injection, rather. Um, the the Orion, the Artemis 1 lifted off from Cape Canaveral, the Kennedy Space Center, uh, November 16th, 2022. It started out with, that red line shows how it orbited the Earth and then did the translunar injection and got to the moon and established an orbit in around the moon. Um, so it went into what was called a distant retrograde orbit, which is the blue line basically there. And that orbit is about 40,000 miles above the moon and uses what's called the lunar Lagrange points for orbital stability. We'll talk about Lagrange points in a minute. It also made another close approach at point 9 there, and then with the yellow line going back and splashed down in the Pacific. It departed the moon on December the 1st and splashed down on December the 11th. So all in all, the mission duration was 25 days, 10 hours. It traveled a total of 1.3 million miles. Its farthest distance from Earth is 268,563 miles, which was the farthest that any spacecraft designed to carry humans had gone from Earth. I mentioned that the distant retrograde orbit uses Lagrange points, and you've probably heard about Lagrange points with respect to the Earth Lagrange points, where it's a very stable area where the gravity is kind of between the Earth, the Sun, and centrifugal force all kind of balanced. For example, the James Webb Space Telescope uses the Earth's Lagrange 2 point and orbits there which keeps it in the same um, um, aspect to the Earth all the time throughout the orbit, the same relative position to the Earth around the orbit without using very much fuel. That's about 1 million miles from the Earth. The moon also has Lagrange points. Lagrange 1 and Lagrange 2, here you see in this diagram, are about 38,100 miles. So about 40,000 miles from the moon puts you very near the Lagrange point and provides for a very stable orbit around the moon without using very much for maneuvering thrusters.
Dave, can I ask a quick question?
Absolutely. I'm going to pause right here.
Sure. In this diagram, where's the sun? Is it ahead of the L3 point, or where would it be?
Well, the sun is way to the left. So the Lagrange
To the
points for
left.
the moon yeah, and so the Lagrange points for the moon really use the Earth and the moon uh, uh, more so than the sun for the gravity for the Lagrange points.
Got it.
Whether it's more
I
the
don't
Earth and
see.
the sun for the Lagrange points for the for the Earth.
Got it. I don't see any comments in the chat. Does everybody have any questions right now for Dave? Have anything discussed so far? Okay.
I'm
Got
gonna
a
start
quiet
moving to the
crowd.
more
Go ahead,
interesting
Dave.
part. Well, we're going to go to Artemis 2 now. So this is now we're going to start getting into the crewed mission. Uh, it's now set for April of 2026. So this is the Artemis 2 will be the first crewed mission, meaning uh, CREWED mission, right? Um, beyond Earth low orbit, and will include the first woman, the first person of color, and the first non-American uh, for flying to the moon. Uh, Commander Reed Wiseman, uh, pilot Victor Glover, payload specialist Christina Cook, and the mission specialist Jeremy Hansen, who's from Canada. Um, so Cook, Glover, and Hansen are planned to be the first woman, the first person of color, and the non-American to go beyond Earth orbit. This mission will pave the way for Artemis 3, which will have the first woman and the next man to land on the moon. The goals for this mission, so they're not going to land on the moon. They're just going out and orbiting the moon and coming back. They're going to check out life support systems, performance of the Orion crew capsule, the communications and tracking systems, and testing of a radiation shelter. So this is going to be the path for Artemis 2. It'll launch from Cape Canaveral using the Space Launch System. It'll move into low Earth orbit before jettisoning the core stage. Then after checking that systems are working as expected, that interim cryogenic propulsion stage, the ICPS, will move Orion into an elliptical orbit. And that orbit will be at its closest approach 115 miles above the Earth and at its farthest point, 1,400 miles above the Earth. So just as a kind of a reference point, the International Space Station orbits in a nearly circular orbit at about 250 miles above the Earth. So after one orbit, that ICPS will then fire again to achieve what's called a high Earth orbit. And it's going to be another elliptical orbit with the same perigee at 115 miles, but it will go out to 46,000 miles and take about 23 and a half hours to do one orbit for that. This maneuver will give the spacecraft the necessary speed to enter the translunar injection. At that, after which they will separate from the ICPS. The crew will move spacesuits and spend the rest of the trip in plain clothes and check out the communication systems. Um, after so that's all kind of in that green, and then they use that translunar injection burn to send them to the moon, and that from that point um, near the Earth there, as it moves toward the moon, after they do that burn to get into the translunar injection, they won't need to burn that engine anymore. The speed and the trajectory is what's called a hang on a second, let me get this. It'll use the Earth and Moon gravity for what they call a lunar free return trajectory. So it'll go out to the moon. It'll use the moon's gravity to go around the back of the moon, which will send it back to the Earth, and then the Earth's gravity will bring it back. And they won't need to use the main engine at all, just maneuvering thrusters for the entire trip. It'll take about 4 days to go from the Earth to the moon, and they will go around the moon, be about 4,600 miles from the moon on the far side, and then use the Earth Moon gravity. They will pass by the moon and return to the Earth. Another 4 day trip back. That's kind of the blue line there, and then land, splash down in the Pacific Ocean. Okay, so that's the plan. Now, originally Artemis 2 was to launch on September 2024 last year, and with Artemis 3 about a year later, but they've been delayed with a couple of issues. When Artemis 1 came back and they inspected the heat shield, they found that there was some unexpected erosion of the material on the heat shield. And so they wanted to investigate that and see what changes needed to be made to try and get that beefed up a little bit so they would have better burn on the heat shield. They also discovered a design flaw in Artemis 3 electronic circuit that drives the valves that are associated with the life support system. Now, this this same system passed acceptance testing for Artemis 2, but NASA is going to replace these valves for Artemis 2 as well, just as a little bit of added safety feature on that. And then there was a concern the launch abort system that doesn't have the power margin necessary for the vehicle would need to separate all and go all the way to landing. And so they're also taking another look at that. These delays also give SpaceX more time for development of the Starship human landing system, and then the Axiom space uh, companies lunar spacesuits that they're developing as well. So I'm buying a little bit of time on that. Any questions about that? That's the end of Artemis 2. We're going to talk about Artemis 3 here in just a second.
So yeah, we do have some questions now in the chat. Lux asked, was reusability considered for the RS-25s, which I think are the rockets, right?
Those are the rocket engines. Uh, no, the Space Launch System is an expendable system, so they're going to be that they're reusing. Uh, uh, I should say they're using rockets that were created for the space shuttle. I don't know that they're reusing any. They might be. I'm not sure.
Okay. And then David Wilhelm asks, with the recent anti-DEI initiatives, is there any chance Trump will force a crew change? Have you heard anything about that?
Not heard about a crew change. I've heard about some other things, which we'll talk about at the end. But I've not heard about a crew changes yet.
Okay. Does anybody else have any questions at
DEI,
this time?
yeah, I would hope that they wouldn't change the crew just because of DEI. These are highly trained people. I don't care. I don't care if they're men, women, or what their nationality or race is. They're all highly trained.
Plus, if they were to do that now at this late stage, it would really delay things, wouldn't it?
It would delay things a lot. Yeah, this crew's ready to go.
I don't see any other questions, Dave. So back to you.
Thank you. Artemis 3, return to lunar surface. Okay, that's launch is scheduled for mid 2027. It'll be the first crewed landing on the moon since Apollo 17, using the Orion spacecraft to transit to the moon. The SpaceX Starship human landing system will be used to land on the lunar surface, and there are some prerequisites before we do that. So this will mark the first time we will land back on the moon, and we will have, hopefully one woman and 3 men to land back on the moon. The prerequisites. Let's talk about that. First of all, we're going to talk about the commercial lunar payload services. Okay, so like Apollo, NASA wants to research the area where they are planning the Artemis landings. And in order to curb the cost of developing and sending their own spacecraft, NASA is hiring commercial companies to do this for them. And so that the whole program is called the Commercial Lunar Payload Services. Uh, they are hiring companies to develop and send small robotic landers and rovers to the moon. It allows rapid acquisition of lunar delivery services from American companies for payloads that scout for lunar resources, test in situ resource utilization, perform lunar science, and just support the Artemis lunar program. So far, NASA has awarded 8 CLIPS, that's what they call it, CLPS, CLIPS contracts uh, at about 2.6 billion, and they are considered indefinite delivery, indefinite quantity contracts. Okay. So if we see here the various locations where they intend to send these missions, they're both on the near side of the moon. There's a couple on the far side of the moon. There's also they're going to have an orbiting spacecraft we'll talk about in a little bit, and then there's also 3 that are planned to be landing near the South Pole. Okay. The first mission to go up was the Peregrine Mission 1. It was astrobotic technology. developing space robotic technology, and the United Launch Alliance, which is the contractor to NASA for launch vehicles. It was launched in January 8th, 2024, carried two rovers. One was the Viper, which is the Volatiles Investigating Polar Exploration rover that was a NASA rover, and then also a Cube rover that was developed by Astrobotic. It also carried several NASA spectrometer experiments, a German radiation experiment, a Mexican experiment that I couldn't quite get details on, and some time capsules from several countries. Um, it the launch was successful, but after launch, they found that there was a propellant leak uh, on the spacecraft that did not allow it to get to the moon, and so the mission was abandoned, and subsequently they directed the spacecraft into the atmosphere of the Earth, where it burned up over the Pacific. The next launch is the IM Odysseus, which is the Nova C lander made by Intuitive Machines and a SpaceX launch vehicle. Um, it launched on February 15th, 2024, aboard the Falcon 9 rocket. Its original destination was actually between the Sea of Serenity and the Sea of Crisis on the near side of the moon, but later it was decided uh, to change the location to near the South Pole to investigate possible water sources for a lunar base, and that's number 7 there on the map there where they land. And it landed on the moon on February 22nd, 2024, with 6 NASA instruments and 6 commercial instruments. Now, the landing was a little rough when it came down. It came down at an angle, and when it impacted the surface, it actually broke one of its 6 struts, and so it wound up sitting at about a 30-degree angle. This Even at that, the science instruments were still able to function. This was a rather significant landing in that it was the first time that an American spacecraft had landed on the moon since Apollo 17. It's the first time that a commercial spacecraft had landed on the moon, and the first time that a private company had a soft landing on the moon. The NASA instruments that were on there had a laser retroreflector array, uh, a LiDAR navigation device for measuring distance, a stereo camera, low frequency radio receiver, a lunar Node 1 beacon, which is a CubeSat side experiment for autonomous navigation, and an instrument to monitor propellant levels. The commercial experiments that were on there was a radio wave observations of the lunar surface. They had a CubeSat that was to be ejected out of the side of the aircraft about 30 meters before it landed to record the landing of the spacecraft. And then a Lunar Prize Memorial Time Capsule. They also had a Moon Phases Art Cube, a arts type of thing, an Omni Heat space blanket, and an independent lunar date test mission. So for about 7 days, it performed its experiments successfully. The company stated up front that they did not expect it to survive the lunar night, which is 2 weeks long. So on February 29th, the Odysseus lost power as the area fell into the 2-week lunar night. And then when it came back into the sunlight, they tried to reestablish communications with it, but was unsuccessful. So the mission officially ended on February the 29th. The next commercial lander is the Blue Ghost lander by Firefly Aerospace and SpaceX. It's interesting because a lot of these companies I've never heard of before. So uh, if you haven't heard of them, don't feel bad. These are people who have been apparently in the space industry, but not the big names that we normally hear about. The Blue Ghost lander is manufactured by Firefly Aerospace of Cedar Park, Texas. Um, you can see that it was a $93 million contract. It was launched just this past January 15th, 2025, on a SpaceX Falcon 9 rocket with a targeted lunar landing on March the 2nd. So this is the trajectory of the Firefly spacecraft. Uh, it's going to start out by doing by orbiting the Earth for about 25 days, testing out systems, making sure everything is good to go. Um, Tomorrow, what's planned for. They're going to actually make their translunar injection and fly out to the moon, arriving at the moon about February 13th, and then they'll orbit the moon for about 16 days before descending to the lunar surface in early March and conducting surface operations for 14 days. The Blue Ghost mission, it's going to land at number 3 there on the diagram. It's the Mons Latrell is a volcanic feature that they're landing near. You can see the various experiments there, but just that's kind of it as a summary. These 10 experiments will test and demonstrate lunar drilling technology, regolith sample collection capabilities. The regolith is like just lunar rocks and soil. Global navigation, satellite system capabilities, the radiation tolerant computing, and lunar dust mitigation methods. So it'll be exciting to see how that turns out. These are some of the upcoming CLIPS missions. Um, we have one that's supposed to launch in late February, and last time I checked, this was on schedule. I don't have a specific date, but they're going to be launching in late February with the destination of the South Pole. They're planning to drill and collect and analyze subsurface ice on that particular mission. You can see the other missions that are here later this year, September and October. 2 more missions are planning on going, with 2 more missions in 26, and a couple of missions after that. These various payloads, the Griffin mission 1 is going to have a Viper on it as well, but that's been canceled now. The LRA is the Laser Retroreflective Array again. They'll have a Cube rover and Land Cam X. Moving down here, the Moonlight, ESA Moonlight. Moonlight stands for the Moon Laser Instrumentation for General Relatively High Accuracy Tests, and is basically a laser retroreflector developed to complement and expand on the lunar laser ranging experiment that was started with the Apollo program in 1969. That Lucy Light stands for Lunar Surface Electromagnetic Experiment, and is a suite of sensors and electronics that's designed to measure the character and characterize the electric and magnetic field environment of the lunar surface from DC to 20 megahertz. Then you see Lucy Night. Lucy Night is a planned robotic radio telescope observatory to land on the far side of the moon and function from there. And then the Elytra is going to be an orbiting vehicle that will provide on-orbit transfers, hosting, delivery, and servicing. And finally, that Prospect, the IM-4, is a package for resource observation and in situ prospecting for exploration, commercial exploitation, and transportation. I don't know much more than that, the ESA payload. Any questions about the CLIPS program?
I don't see any questions in the chat right now. It looks like things are ramping up now over the next 2 years or so with all these missions.
Yeah, but if they're successful, I wouldn't be surprised to see a new round of contracts go out.
Dave, it looks like the missions you have here are NASA and ESA specific. Do you know of any that the other nations are trying? Any Chinese or Indian or Russian or anybody
I
else?
don't. These are missions specifically in support of Artemis. There are missions
Okay.
being. I'm sure there's missions. I'm sure the Chinese have missions coming up. I know that they've got a couple of missions coming up, and India has been pretty active too. I didn't research those to see which ones are coming up right now.
Sounds good. Does anybody else have any questions right now for Dave on this subject?
The Japanese have a Hakuto R on the way to the moon as well, right now.
Okay. All right. Do you know what that's planned on doing for the mission? Okay.
VT. It looks like we lost it. There you are.
All right. Okay, so now let's talk about human landing systems. We mentioned that the Orion capsule will be going to the moon, and then the human landing system will bring them down to the surface. So, to ensure that, so the human landing system is actually separate. Um, to ensure continuous human landing services and reduce the risk of developing these systems, NASA has partnered with 5 companies to develop these human landing systems: Blue Origin, Dynetics, Lockheed Martin, Northrop Grumman, and SpaceX. And each of these are creating unique lander designs based on NASA requirements. 3 contractors have responded to the request for bid, and those are the 3 landers we see here. On the left is the Blue Moon lander by Blue Horizon, and the landers being looked at to be used with the Lunar Gateway. The Dynetics Alpaca, which is an acronym that stands for Autonomous Logistics Platform for All Moon Cargo Access. And then the SpaceX Starship Human Landing System, which is the one that's going to be used with Artemis 3. Okay. The SpaceX launch system. Uh, so, unlike Apollo, the Orion spacecraft is not going to take its human landing system with it. They're going to pre-position the human landing system, and Orion is basically going to be transportation from the Earth to the moon and back. Okay. So the SpaceX is developing the Starship human landing systems, and it's going through some tests right now. The last test wasn't real successful. They got it off the ground, and I think uh, the Starship itself exploded after launch. Uh, but it uses the super heavy first stage of thrust to take off, and then they have the different variations of the Starship at the top. We'll talk about in just a second. Um, and they're planning on having an uncrewed lunar landing and ascent test yet this year. So we'll see how that goes. There are 4 different variants of the Starship. There's a cargo Starship, a crew Starship, a fuel depot Starship, and the lunar Starship. Okay, the first 3, the cargo, crew, and fuel, are designed to return back to the Earth. The human landing system, lunar Starship, is not intended to return to the Earth. It's supposed to be positioned at the moon. Um, so how it's going to work for getting the human landing system to the moon is they're going to start out by having a Starship fuel depot spacecraft launched and put into orbit around the Earth. And then a series of replenishment spacecraft will be launched, and each replenishment spacecraft will rendezvous with the Starship fuel depot and refuel the Starship while orbiting the Earth. And this could take up to 10 different launches to completely fill this fuel depot Starship. Then the Starship human landing system will launch, and it will rendezvous with the fuel depot and be refueled after launch, and then it will continue on to a translunar injection and placed in orbit around the moon, where it will be used to transport uh, humans from lunar orbit down to the surface of the moon. They're going to place the Starship HLS in what's called a near rectilinear halo orbit, which I will talk about a little later. The halo orbit is the main thing, though. Is it's again one of these uh, elongated orbits where it has a very close path to the moon and then goes out well beyond the moon, out to one of the Lagrange points to provide a very stable orbit, which requires very little fuel to maintain. So here for Artemis 3, then, once the human landing system is in orbit, that's that gray line around the moon. That's the human landing system is in orbit around the moon. Then Artemis 3 will launch. The core stage will place Orion into Earth orbit. And then we have the green line there where it will assume a trajectory to the moon. It will fly fly to the moon and get into the same halo orbit as the human landing systems, and will rendezvous with the human landing system in orbit. It will dock. It will dock with the human landing system, and then the astronauts will transfer from Orion to the human landing system. The human landing system will then separate from Orion and go down to the moon surface. On the right there, you can kind of see those, the top one would be the descent down to the lunar surface. And then they would spend about a week on the lunar surface doing exploration, and they would be collecting samples and the like. And then they would launch from the lunar surface, go back up, and again dock with the Orion capsule in orbit, and then transfer anything they have from any samples or the like from the human landing system to the Orion spacecraft. The spacecraft, they would all get to the Orion spacecraft, separate from the human landing system, and then assume a trajectory back to the Earth, landing in the Pacific Ocean. The lander, the human landing system itself, uses a mid-body thruster to avoid disturbing the lunar regolith when it lands. Uses gaseous oxygen and methane instead of liquid oxygen and methane. And once on the moon, the astronauts will spend about 10 days. And you can see the size of this thing. We got little astronauts down there at the bottom of the human landing system. This is a rather sizable spacecraft. And they will do their science and the like. The initial mission is planning on bringing the Lunar Environment Monitoring Station, which is an autonomous seismometer suite. The lunar effect on agricultural flora, which investigates the impact of the lunar surface environment on space crops. And the Lunar Dielectric Analyzer, which was developed internationally and will measure the regolith's ability to propagate an electric field. They're planning on bringing 87.5 pounds of lunar material back, and they'll again rendezvous. The potential landing sites for this in the lunar South Pole area, there's 13 of them that have been scattered out. The Lunar Reconnaissance Orbiter has done some extensive photography of these, mapping the lunar surface, mapping the changes in the lighting throughout the lunar month, and so on and so forth. Which landing site they will use will depend on landing safety, the ability for a rover to move around, the proximity to shadowed areas that could contain water, ice, and just generally what the science objectives are. Okay, so that's the end of this Artemis 3. Is there any questions about Artemis 3?
So we do have a question in the comments in the chat. I'll just go through them one by one here. Mark had asked, is it true the moon is receding from the Earth in its orbit? And I actually answered that for him. It was the moon is receding at about 3.8 or 4 inches per year,
Right.
centimeters per year.
I was going to say
And
it's actually centimeters, right?
Yeah, roughly 4 centimeters a year. And I did a little more math on that. Every million years, it comes out to about 21 miles. So it's receding, but not too quickly. Let's see.
It's
then
not a
Ben,
concern. It's not a concern for this particular mission.
not in a human lifetime anyway.
Right.
Ben made a comment that he thought that the Dynetics contract did not extend to the next phase.
Okay.
I don't know if Ben, if you want to add anything to that. Alan Touchberry commented, answering someone that asked about commented about the Hokkaido mission. The rover is to be deployed. It launched on January 15th and it will land in Mare Frigoris on the moon. I don't know, Alan, if you want to add anything to that. And then Lux asked a question here. It's a little bit longer. I know that SpaceX frequently talks about how it's using the HLS for Artemis. I have heard from an engineer as part of a meeting for NASA's Hunch program, for which I'm designing a hypothetical landing system, that Starship wasn't ideal for their purposes, citing difficulty in landing on its tail, hence the Hunch project. No effective payload to surface delivery. Astronauts can't get down efficiently. hasn't demonstrated any of these capabilities yet, even on Earth, and hasn't demonstrated that it doesn't blow up every few launches. And that there might have been plans for another ship being used. Has there ever been any talk on public channels of NASA about using an in-house landing vehicle, other contractor for human landing?
Say that last part again. In-house.
Uh, has there ever been any talk on any public channels of NASA about using an in-house landing vehicle or another contractor? I think aside from SpaceX, I believe, for human landing.
Okay, so I mentioned there are five contractors total, okay, for the human landing systems. I've not heard any talk about NASA developing one themselves. Okay, um, as far as using another contractor, um, none of these have really demonstrated themselves as yet. So you're right uh, that SpaceX has yet to really demonstrate that theirs works. But then again, all the other contractors have yet to demonstrate as well. So it's all kind of a work in progress right now to get to that point. Could it affect timelines? Sure. I mean,
Blue
all that stuff
Origin
affects
did
timelines.
submits a bid, but they were like 4 times over the amount of money that the program had to spend, so they weren't considered.
Right. But the only person for this, for at least for Artemis 3, as far as I know, the only contractor came in that they wanted to use was the SpaceX. And SpaceX has demonstrated its ability to land, right? Because they land their boosters all the time. Um,
Mhm.
so so they have done that demonstration. Now you're right, they haven't landed on the moon. They haven't successfully demonstrated they can get the Starship there yet. So there's some work to be done, no doubt.
Yeah. I mean, one concern that I have is, you've seen on some recent landings on the moon where the struts have not survived the landing, right? They've been crunched. So if you're going to land on four, I guess, struts, is there a concern that, what happens if one of them breaks and it either topples over or can't be
Right,
accessed?
right. Yep, yep. All that's a concern, I'm sure.
Are there any other questions for Dave at this time or comments? All right, Dave, back to you.
All right. So after Artemis 3 comes Artemis 4. Okay. And the Lunar Gateway. So the Lunar Gateway is going to be an ISS-like space station that's going to orbit the moon. Um, Built with both commercial and international partnerships. Um, and it's going to be kind of a modular construction, just like the International Space Station was. There'll be um, two components that will be pre-positioned, and we'll talk about that in a minute. And then the Artemis 4 mission will add the IHAB module, which I'll talk about in a second. Artemis 4 is not scheduled to launch any earlier than 2028 at this point. The Lunar Gateway will start with the pre-positioning of the PPE and HALO modules. The PPE module is the power and propulsion element. It's built by Maxar, and it will provide the solar electric power, the solar electric ion propulsion and communication center. And then the HALOs, the habitation and logistics outpost, uh, that'll be built by Northrop Grumman Innovation Systems. And it's going to be a pressurized module with command and control communications and data handling capabilities, the energy storage and power distribution with batteries provided by the JAXA, which is the Japanese Aerospace Exploration Agency. The life support systems capable of supporting a crew a crew of 4 for 30 days, and then docking ports for the IHAB module, for the human landing system, and 2 additional ports. There's also going to be a connection for the Canadian-built Canadarm3. HALO will have a suite of instruments designed to improve our understanding of space weather and prediction models, and will also have the European Radiation Sensors Array to measure the effect and impact of solar radiation on astronauts and equipment. Okay, and it also We also see here where SpaceX is going to send a Dragon XL logistics module with experiments and supplies, and an upgraded Starship human landing system will also be sent to provide expanded capabilities for long-term exploration and gateway docking. After pre-positioning this, the Artemis 4 mission will be on the SLS Block 1B, which has that larger service module. That the upper stages of that has more than 10,000 cubic feet of space and will contain the IHAB module for the flight. Once it gets into orbit and does the translunar injection, then the IHAB module, which is built by European Space Agency, the Orion spacecraft will disconnect from the adapter ring, rotate 180 degrees, dock with the IHAB unit, and extract it from the adapter. And then they will travel together to the moon. And then once they get to the moon and into the to the gateway, then they will dock with the gateway and attach the IHAB module. The IHAB is the International Habitat Module, and that was built by ESA. So that's kind of where they're going uh, to live on this lunar gateway. So the gateway has a unique orbit. It's going to be the same type of orbit that the initial human landing system will have, called a near rectilinear halo orbit. On the right, you see the three different types of orbits that they typically have around the moon. One is a low lunar orbit, which is what most spacecraft have done so far. In fact, most of them. It's a low orbit, easy access to the surface, also can do good science on the surface. The problem is that the moon has a lot of gravity wells, and so it takes constant maneuvering to keep you into the right orbit. And so it uses up a fair amount of fuel over time. The distant retrograde orbit, which is what Artemis 1 had, it's very large circular orbit using the Lagrange points for the moon. It's about a 2-week orbit, but it's very stable and requires very little maneuvering thrusters. But of course, it's about 40,000 miles from the surface, so the access to the surface is not, very good at that distance. The halo orbit is a elliptical orbit where you have a close pass to the surface and then go out to a much larger distance using the Lagrange points as to help stabilize the orbit. And so this orbit is about 1 to 2 weeks, but it is uses very little fuel for maintaining orbit, and does provide a pass every orbit close to the surface where you can go down to the surface or return from the surface to the gateway. And so it's kind of the best of both worlds. So on the left, you'll see, and I'll explain the near rectilinear part of this. So you can see where you have access, you do science when it's close to the moon, and then you can do communications, some surface operations, and environment type of things when it's farther away from the surface. The near rectilinear piece of this is when you combine the halo orbit with the movement of the moon around the Earth. This is the path that the spacecraft will take overall. And you can see that, it's got the halo orbit where it comes close to the moon and then comes back out. And it forms roughly a rectangular shape over the course of the moon, over the lunar orbit. It's nearly a rectangle, hence the near rectilinear, and it's a halo orbit around the moon. So it's a near rectilinear halo orbit. And for Artemis 4, going to be not unlike Artemis 3, they'll launch. They'll start their translunar injection, during which time they will go ahead and do the maneuver to attach to the IHAB module. They will then proceed to the moon. The gateway will be in that gray orbit around the moon. They'll go ahead and rendezvous with the gateway, attach the IHAB module, and the human landing system will be pre-positioned as well there. So it will be already attached to the gateway. So they will go ahead and go from the Orion into the lunar gateway, and then subsequently into the human landing system. During a close approach to the moon, the human landing system will go down. They'll land on the moon. They'll conduct their operations on the moon. Next orbit, they'll launch back up, rejoin the lunar gateway, transfer items that they got from the surface into the gateway and then into the Orion capsule. And then everybody would pile into the Orion capsule, separate from the gateway, and come back to Earth. That's basically the way it works. The lunar gateway, when it's finished, will be kind of composed of all these different modules. It's a multinational collaboration with participants including NASA, European Space Agency, the Japanese Aerospace Exploration Agency, or JAXA, the Canadian Space Agency, CSA, the Mohammed bin Rashid Space Center in United Arab Emirates, and then SpaceX and other commercial companies. So you can kind of see all the different components of this. And then just moving along, harnessing lunar resources. After Artemis 4 will be Artemis 5 and 6, and they'll continue building and integrating the lunar gateway. They're going to establish a base camp in the early 2030s. And then the subsequent Artemis missions would have longer stays on the surface, delivery of lunar surface logistics. Artemis 5 currently is planned for 2030, Artemis 6 for 2031. The Artemis Base Camp is located near the Shackleton and Gerlach craters near the South Pole, where they have access to water. A wide variety of lunar geography. Again, like I said, the proximity to shadowed craters and water ice in the soil. They also, in the center of this image, you see this rather large rover. It's a pressurized rover that can travel large distances, and the crew can live on board for multiple days. So that's kind of the long range vision into the 2030s. Any questions about that?
Yeah, let's see. A comment from David Wilhelm. Unlike Apollo, actually a question. Will all Artemis astronauts after the initial test missions actually land on the moon?
After
sure
Artemis
what-
2, after Artemis 2, the intention is for all the astronauts to eventually be on the moon. Yes.
Dave,
Oh,
have you?
So when I say all astronauts, let me rephrase that. I think the intention is to have astronauts land on the moon. Will all the astronauts going to the moon land on the moon? I don't know that. I think they'll still keep astronauts on the gateway, for instance, to maintain communications and the like. I think it'll be similar to the Apollo command module lunar lander concept, where you have people who go on the human landing system to land on the moon, but there'll also be an astronaut or two that will be in the command module, so to speak, the gateway.
Dave, if you remember back during the Apollo missions, the astronauts came back with but dust pretty much everywhere. Like this lunar regolith, this dust there is really, I don't know if the word is thick.
It's dust mitigation. Yeah, it's a problem.
It gets
Yeah.
everywhere. So I look
Yeah,
at
it
your
does.
picture here. How are they going to deal with that? It's going to be
Well,
everywhere.
yeah, I agree with you. And you'll note that there are some CLIPS missions that are going up that are going to address that whole lunar dust problem and see if they can come up with ways to be able to control that. You're absolutely correct. The lunar dust is a problem, and they're going to have to figure out some way of mitigating that.
Lux adds to that. The dust is actually also an active concern. One of the Hunch projects is designing parts of a tarp system to put down to hold the dust down.
Yeah, right. And I mentioned that the SpaceX Starship landing system has rockets that are midway up the rocket to keep it from kicking up dust on the surface as much as possible.
Any other questions for Dave right now? Anyone? Guess not. Back to you.
Yeah, I'm going to end this with a couple of comments. Okay, so the Artemis program is not without its criticism. Okay, um, Robert Zubrin is a kind of a expert on space exploration and lunar missions, as well as Buzz Aldrin, who's an Apollo 11 astronaut. Uh, they both question the use of the intermediate point, the lunar gateway, before descending to the moon. They're kind of advocating, let's go directly to the moon and let's not uh, mess with having an intermediate stop around the moon before descending to the moon. So just interesting that they're kind of voicing their they think there's a lot of time and expense associated with that that they could better use by going directly to the moon instead of using this intermediate stop. The other criticism is in this whole fuel depot refueling thing, where you have to refuel the HLS and you have to refuel the fuel depot first with 10 additional rocket launches. Each rocket launch has its risks, and 10 is an estimate. It may take more than 10 launches to do that. So there's some criticism about, again, the use of this fuel depot and all of that. And finally, today, an article came out in Reuters where Boeing has announced to their employees that the SLS contract may be canceled in the next few weeks. That would put a big crimp into this whole program. So I don't know what the future holds.
Dave, would you mind elaborating on that a little bit? Like, why would they want to do that?
I cannot elaborate on it because the article didn't elaborate on it. All the article said was that Boeing was telling its employees who are working on the SLS program that it's likely that it's going to be canceled in the next few weeks.
Okay. I mean, we know that the average cost for each launch under the SLS program is going to be in the $5 billion price range, something like that per launch. So that's going to be part of that reason, right? If they do that.
Well, yes, I'm sure that money is part of it with the current administration's view on cutting back on government spending. There's also we have part of the administration, the Elon Musk, who has a definite interest in all of this and probably has some opinions about how the space program should move forward. Don't know what they are,
Right.
but
because the estimate is that SpaceX and Blue Origin both can launch similar or more weight capacity for roughly 1/10 the cost. Isn't that the idea of what
the
they're
idea. They
saying?
haven't demonstrated it yet, but yes, that's the idea.
Not yet. Yes. Yeah, I was very careful on how I worded that.
No, I understand.
Does anybody else? Let's see. I'm looking at the comments here. Let me catch up. Ben says that one of the Firefly experiments will test electrostatic dust repulsion. If no lunar gateway, then you need a much bigger launch vehicle. And then, okay.
Yeah, if you're carrying everything with you, yes, that's true.
And then Lux added an article from Reuters about, I don't know, Lux, what did they say in the article? Just about the layoffs with the SLS program? Yeah, many layoffs relating to Artemis. There's an article that Lux included in the chat. And then up to 400 people apparently might get laid off. And then Michael Haas says, given NASA's limited budget and given the spectacular success of NASA robotic solar system exploration and robotic telescopes, not to mention the successful Chinese lunar sample return missions, how can we justify development of vastly more expensive, risky, and physically limited human exploration? Boy, the big question, Dave.
I can't comment on that other than the fact that I think that and that I think that just the human curiosity of being able to go and as much as you can do with robotics, um, it's still not the same as having an actual human on the surface doing it.
I think
Robotics are
another,
limited by what they're designed to do, and humans have a lot more
yeah,
flexibility in terms of what they're doing.
I think part of that too is, um, in order to capture the public's imagination and keep NASA funded, there has to be a human component involved. Otherwise, people don't have the same. They're not emotionally involved as much if it's just a robotic mission as they would be
Yeah,
with a human one.
but there's, you know, eh, obviously, his um, observation is very good. I mean, we do very well with robotics, right? We've developed some amazing capabilities, but it's not the same as placing a human on. And but to your point, it's a lot more complicated. So
And Alan adds, the announcement was to start the 60-day clock ticking. If a big company is considering layoffs, there must be a 60-day notification.
all right.
And then,
Yeah, and
Bet,
and there probably will be layoffs, but nobody knows for certain. But Boeing decided they had to start the clock ticking.
Yeah.
and then Ben adds, every space mission use humans, sometimes all on the ground, sometimes most on the ground, and a few on site. Remember, it took years for Mars rovers to drive as far as Apollo astronauts drove in a long weekend on the moon. And then Lux commented, keep in mind, though, that getting that rover to Mars was way easier than humans. Uh, Rovers don't need food or water or entertainment or space, only power. And we've got solar panels.
Well, absolutely. I mean, sending humans to the moon is one thing. Sending humans to Mars is a whole different story. And you have to understand that even when Mars is at its closest, which is not going to be until the mid 2030s, you're still talking about months of travel through space to get there and months to return, not days. So you have to, and you also are, when you go to the moon, you're still more or less in the same vicinity as the Earth, with some of its protections, like the magnetic field and the like. You get out interplanetary space, you're subjecting astronauts to uh, space environments that are much harsher, and you better be prepared to handle that. And they're coming up with ways of doing that, but it's much more challenging to send a human being to to Mars or any other planet for that matter than it is to the moon. And of course, a robotic spacecraft doesn't have those issues, those concerns.
Yeah. So Dave, this kind of leads into a question I was going to ask in that. So we seem to have this twin, I don't know what the term is, that we seem to be going on two tracks, one to explore the moon with a manned mission, and another one starting to develop the similar capacity for Mars. Do you think that's the right approach in the sense that some people think, why are we even going to the moon? We should just go straight to Mars. And other people are saying, why bother with Mars? Let's develop the moon first. I don't know what your thoughts are on that.
So my thoughts are that we should go to the moon first. I think we learned a lot by uh, taking a step to the moon and back. It's first of all, it's much closer. If a problem occurs, if we're sending a human to the moon, if a problem occurs, we have a better chance of getting it back, aka Apollo 13. You send somebody to Mars, something happens on the way to Mars, you can be in big trouble. So I think we need to help. I think by traveling to the moon and establishing a presence on the moon helps us to develop the technology and the expertise that we're going to need to travel to the Mars and establish something on Mars. The Martian, we can't breathe the Martian atmosphere, so you know, it's going to be a lot like establishing something on the moon because we're going to need protections and all that. So I do think that that going to the moon first is the way to go, and establish ourselves technologically and scientifically there, and learn what we can before we start going to the moon, going to Mars, right? In my opinion, and I think NASA's too. I think why would NASA go through all this to get to the moon if the intention is just to go straight to Mars?
Does
I know
anybody
that
have any other? Oh, sorry. Go ahead. Keep going.
there are others that have a different opinion on that. That we should go just skip the moon and go straight to Mars. But I think the technological challenges of doing that are significant.
Are there any other questions or comments for Dave? I don't see anything else in the chat. Feel free to just ask your question directly to Dave if you like now. Dave, I think that might be it.
All right.
Okay, much
Well,
appreciated.
thank you, everyone. I hope that the program to get to the moon continues in some form or fashion, and I hope that they are able to do it in a very safe way. I have concerns about a totally commercial mission. So
Yeah, so do I. With Artemis 4, what are they thinking? Artemis 2 is 2026. Artemis 3, 28, and 4, 29. Is that kind of the timeline?
2030. Well,
Sorry,
actually,
say again?
probably closer to 2030 because things unfortunately keep getting pushed out. So they're talking about Artemis 5 in 2030, but I'd be surprised if it's that early. So,
Great.
I mean, we
Well,
don't know what we don't know, right? So we still haven't successfully landed on the moon yet. So, I mean,
baby steps.
baby steps, exactly.
Excellent. Well, Dave, really appreciate it. With that, everybody, I'm just going to do a couple plugs for our next BSIG presentation scheduled for 1 o'clock on Saturday, March 8th. Tom Field from RSpec Spectroscopy is going to discuss spectroscopy, which is kind of a cool area for amateur astronomers. Just a little bit of a background on spectroscopy for astronomy. If you can obtain a spectra of a star, you can determine not only the elements in the star, but also the temperature and the density of that element in the star. Also, spectral lines can tell you if a star has a magnetic field and some of the characteristics. And the width of the line can tell us how far the star is moving out in space. So again, that'll be on Saturday, March 8th at 1 o'clock. And then our final winter presentation for this year will be on April 12th at 1 o'clock, again, a Saturday. And Jerry Jones is going to be presenting some Astronomical League programs that'll help us get back out with our telescopes and help us focus on things to observe in the sky. So with that, this presentation was recorded and it will be posted to our MAS YouTube channel probably on Monday. So just a couple days. So if you missed part of this or would like to watch Dave again, you can do that on our YouTube channel. All of our BSIG presentations are on there. I think there's roughly 15 or 16 of them now. So feel free to peruse that list. And with that, I thank you and we'll see you next time.